So, and good morning, one and all. So I would quickly like to get a sense, like a lot of audience are there, but maybe one or two people just try to like what is your interest and or what do you know about RAG and what is your plan? Quickly, if you one or two sentences, just type in the chat box so that we all understand and then we understand your energy level also. Uh, just quick one sentence about your interest quickly. Yeah, not getting any message till now. Quickly, what is your interest? What do you plan once you understand RAG? Okay, great. Knowledge base. Okay. Hands on. Perfect. Um, Perfect. So better NN. Okay. Anything else? Don't know about RAG. That's great. I think it gives me a sense like where to start and how to pace my presentation. Quickly, some more ideas, some more comments, some more. Okay. Okay. Great. I so don't know about RAG. Great, great. Okay, so I think it gives me some sense, like how to pace my today's session. So let me start quickly. Okay, MSc IT, but still not decided the career path. Okay, okay, okay. So I think we are all good. Let me start. So looks like we need to understand from the basics. So we'll start from a very, very basic +2 level mathematics. And from here, we'll try to build our concept. And then let's see like how it is resulting into something like RAG, which is kind of very hard as in today. And then how it is different from LLM and what is that it gives me extra on top of LM. So that we will understand quickly. So we will start with something called cosine similarity. Okay. So what is a cosine similarity? Do not worry about this vector terminology and so on and so forth. It is very, very simple, basic thing. Some 11, 12 standard calculus. Sorry, vector algebra. But you can understand, even if you don't understand that bit also, we will understand it today. So imagine two vector, you can think of something which has got a sense of direction. For example, if you are pushing something, you are trying some force, that amount of power push that you apply, and also it has got sense like in which direction you are pushing something. So you will realize that if you push something, it has got two entities into it. One is in which direction you are pushing something and with how much, uh, uh, amount of push. So this is something, if you say like, okay, I have a liter of water, which is 5 liter, 10 liter, and so on. Where you say this is a liter of water, you don't feel like having a sense of direction. But when you push something, then you feel like, okay, I have some sense of direction along with some quantity of push. And that is the fundamental difference between a scalar and a vector. So the concept of scalar and vector is essentially, if you feel like I don't need to say like in which direction, that quantity is scalar. But when it comes like you want to say something, but you want to specify what is the direction, then you are actually dealing with vectors. So if you have a vector, then what is the different properties of vector? Um, and if you have a scalar, you multiply scalar, then do you also multiply vectors? Those kind of things are there. But out of all those things, we are going to focus on one very, very tiny part of it, which is called a dot product. So suppose you have a vector v1 and v2. You can imagine a push in one direction and push in another direction. And these two pushes has got some angle in between. You can simply say it is a theta for now. So to put things in perspective, we take help from the coordinate system like x, y. Okay, so pardon me, like it is becoming too mathematical, but you will realize the power in a very short period. So suppose you have a vector v1 and v2. To put things in perspective, we take help from the coordinate system, which is called xy Cartesian coordinate system. Actually, what happens, you want to specify something in space, you need some reference. And the coordinate system is basically, it gives you a reference saying, okay, this is my direction in terms of x, y, z, because the word is three-dimensional in general. And then you have also another thing which is called your origin. That is basically you start counting everything from that point. And at that point, everything is zero. X is zero, Y is zero, and Z is zero. So that's how it actually helps us to understand, like if from this point, this P is how far and in what direction, and this Q is how far from this O, and then in what direction. So it gives me a directional P sense in terms of my spatial representation of things. So vector v1 and v2 representing point P and Q. And for the simplicity in our application, if we say like, okay, their magnitude, that is the length, or the quantity of push, that you can say if it is unit 1, then they become unit vectors. So v1 and v2, both of them are having a magnitude of 1. So this will give me some simplicity in understanding why we are doing this. Then we have to define one product, which is called dot product. In vectors, we can have a cross product and dot product. The outcome of cross product is a vector, and then outcome of a dot product is a scalar. So we are not going into a cross product. If someone is interested, simply do Google or ask any of your chatting AI models. You will get answer in a very great detail. So we have these two quantities, v1 and v2 as a vector quantities, and we want to get a dot product of two vectors, or else you can say it is a scalar product of two vector quantities. So right side you can see it is modulus of v1 and modulus of v2 multiplied by cosine of theta, and the theta is exactly the same thing, the angle between the two vectors. So v1 and v2 modulus is basically, you can say some sense it is the length of the vector, okay, and theta is basically the angle in between. So modulus is basically, in case of a vector, we define square root of sum of squares of the component. So we'll quickly see like how it is calculated. So here we can actually get this cosine theta, that is v1 dot v2 divided by modulus of vector v1 and multiplied by vector v2. And this cosine theta is basically cosine of the angle in between two vectors v1 and v2. This value can range between -1 to 1. Okay, in between there is a 0. This value, if the vector is coming from your embedding of the words, you will see like what is the meaning of embedding. Then this particular quantity is called cosine similarity, and this is the basis for RAG, and the full form of RAG is retrieval augmented generation. So retrieval is happening with the help of cosine similarity. In fact, entire concept of vector database, query of vectors, query from the vector database, sorting, anything that is related to your modern large language model, a RAG, or any other thing, they are all dependent on word vector. And then whenever we have a vector of something, then all kind of query, ranking, those kind of things, similarity calculation is happening using cosine similarity. And that's why we are actually trying to understand the concept of cosine similarity, which is nothing but your scalar product of two vectors v1 and v2, and cosine of theta actually appears in that particular expression. So we will quickly see with some example like how this value is calculated, and we'll come back to our RAG concept. So suppose, for example, we have a vector v1 and v2. So I will be very fast here, but if you have any question, you can simply ask me. So we want to get modulus of v1 and v2. That's how it is calculated, square root of sum of the squares of the components, which is basically 1 and 0.5 in our case. Then you just do the square and do the sum, it becomes 1.25. And in case of dot product of two vector v1 and v2, what we do multiplication of the components and take a sum. So like this, we have 1 is multiplied by 0.5 and 0.5 is multiplied by 1. So first component is multiplied by first component, and the second component is multiplied by second component. And then we simply add. So suppose in our case, I'm just taking a vector with 2 dimension, 1 and 2. But in practice, when you deal with the word vectors and so on, the number of components will be in hundreds. So you can imagine the same concept will be applied in case of 100 by 100 component vectors. So essentially first element multiply with first element plus second element multiplied second element plus third element multiplied by third element, and so on and so forth. And then sum of each numbers is actually the dot product of the two vectors. So this is like this. And then if you do sum, then it becomes 0.5 plus 0.5, and then finally it is a 1. Okay. So we have a scalar product or dot product of two vectors. Then we add that modulus of two vectors. So now we can do calculation of cosine theta. So cosine theta is equal to 1 by square root of 1.25 into 1.25, which is 1 by 1.25, which is equal to 4 by 5. So you can see it is equal to 0.8, which is quite close to 1. So basically in our case, the vectors, they are close to each other because the angle between them is smaller, and then value of cosine is close to 1. So if the vectors are exactly the same, the theta will become 0 and cosine theta will become 1. And if the vectors are at 90 degrees, then cosine theta will become 0. Okay. And then the opposite of this, if the angles are 180 degrees, then cosine theta will become -1. So basically that's how 0 to 180 degrees will give you cosine theta of 1 to -1. And each of the relations between two vectors can be estimated using this cosine theta. And from there we have to convert into the meaning, like if the closeness is more or less, then what is the meaning, and that we have to exploit in our retrieval. So so this gives you a kind of understanding how the cosine theta is calculated between vectors, and the same concept is utilized in our concept of retrieval. So we'll go back to our VS Code. Meanwhile, if there is any question, we can take quickly. Do we have any question? Okay, so looks like we are all good. Okay, so I'm going ahead. Okay, no question. So I understand, like we understood the concept of scalar product and cosine theta concept and how we are going to use it. So we'll see in detail like how we are going to use this. So now going back to the way computer understands a word. So when it comes a computer, so basically we have 0 and 1 in a given computer. So entire computer storage, algebra, all the calculation, they actually happen at the 0 and 1 level, that which is called your Boolean algebra. Okay, so basically it understand every 0 and 1. So to store your word, it understand each word in terms of a sequence of alphabet, and each alphabet is given you can say here, you can say I am talking about 8-bit concept. So each alphabet is given 8 spaces to represent its value, and then each alphabet is given a number, and that number is converted into a binary representation, which is 0 and 1. Okay, so I hope my screen is visible and you can see it easily. Hope it is making more clearer. Okay. So here you can say MAN, that is man, is represented by M, basically this number, then A, this number, and N, this number. So in a computer, it is man is stored like this. So now you can imagine, for a computer, man is equal to this particular sequence of 0 and 1. Similarly, for a woman, this is like this. This is a very simplistic representation just for understanding. So here I am using 8 spaces. So you can see it is 8-bit representation of something. But right now our computers have 64-bit. So when you say 64-bit, meaning M is written in 64 spaces, or 64 spaces are reserved for writing M. Similarly for A and for it. So it will become long string. I'm just putting it so that whatever is the corrects we understand. Number of bits is for different reasons, but the way it is represented will remain the same. Only the spaces allocation will change from different bits. So man is written like this and woman is written like this. So basically the problem statement here is, for a computer, what it understand if I give two strings. So for a computer, there are only two relationships defined. One, man is equal to woman here, or man is not equal to woman. So only two things it understand, meaning there are two strings. Computer will say, yes, these two strings are exactly the same, or they are not same. There is no concept in between. In the sense, it does not say like man is close to woman by 75%. There is no such thing for computer. So if you look at numbers, then computer is more smarter in numbers actually, because it has got a sense like which number is small, which number is big, how close they are, what is the difference in between these numbers. So numbers, computer can understand numbers in a very, very great detail. It has got a lot of sense about numbers. But when it comes to string, it does not contain any understanding of the string. The entire concept of large language model, or you can say this natural language processing, is basically is to give the computer some sense of those strings so that it can take certain decision based on the strings. Okay, so this entire you can say science and technology is around that particular approach. And our current development, that large language model, is actually the latest thing that has come, and now it is making computers very, very smart. It can talk to a human being, they can answer questions asked, and so on and so forth. So how it is happening, and then in case of, in the context of RAG, how we are going to use that, we will see. But there are a lot of things that is happening in this space. For example, this large language model using transformer technology. They are like very, very complicated things. So that is not the topic for today, but we will try to make it simpler. We'll look at the concept, core concept, and then understand the application of it. So this much we understood, like how computer understand two strings and how we are going to make it understand more than what it is doing, just by comparing two strings. So for example, if I take a word which is called I am a man, and there is a word two that is saying that my wife is a woman. Okay. So what is happening here is I'm actually converting these two words into vectors. The word vector 1 and vector 2. So now you can imagine there are two things. There is a string. The string is stored in a computer in a binary manner, 0, 1, 0, 1, 0, and so on. Now we are taking those set of strings and converting into vectors, exactly the same vector that we have seen. The vectors what we have seen is very small, it is 2-dimension. Here the dimensions of the vector will be more. But the word now or the sentence now for me is a vector. Okay. So we are going to deal with vector instead of dealing with string. And that is going to give us more power. Now there will be a question like, how do we convert our string or a sentence into vector? That is actually happening through word embedding. So what is a word embedding? How do we convert a text into a vector? That is a completely separate technology. The Google is pioneer into this, and then they have a lot of models, and then other people also came up with different models. So as on today, there are a lot of models that have been made. If you pass your string into the model, it will give you straight away, it will give you a vector. Okay, that is your vector representation of the word. However, there is no single standard for the representation. Many people have come up. In fact, you can say it is evolving field where people are still trying to come up with the vector representation. And as strong as you create your vector representation, it is going to be like more useful and more meaningful. So it is kind of a, you can say it is still evolving field, and newer model are coming. So if you can see, like I am using this something called embedding. Okay. And if you see that this embedding, I am importing it here. Here. Okay, embedding. And for embedding, I'm using this Hugging Face embeddings. So this Hugging Face is a website. They have this embedding model. I'm using it. And for embedding, they have got different models. You can see. Okay. So this particular model is going to give me my vector representation. But there may be so many other embedding models that you can utilize and get your vector representation. So this is one of them. Okay. So now we have converted these two sentences into vectors. And then if I try to see like how this particular vector looks like. So just to make the thing simpler, I will drop this part and then only keep man and woman just to understand if man is understood by computers using vectors, then it looks like this. Okay. So I am showing only first 5 elements of the vector, but it has got 384. So I was saying there are hundreds of components in a vector which we are going to deal with. So man is converted into a vector with 384 dimension. Woman is converted into a vector with 384 dimensions. And if I say like what is the cosine similarity? So we say it is nothing but np dot vector v1 and vector 2. So vector 1 and vector 2, basically this is the dot product and this is divided by this is the amplitude. The exact same formula that we have seen in presentation, that is basically your 11-12 standard vector algebra. So this we have simply done this calculation, and then we are getting this number, which is basically, it is saying man or woman are close to each other, and the cosine theta for these two vectors is 0.32. If I take like man and uncle, let me say man and man. Okay. So it is giving me exactly 1 because the vectors are exactly the same. If the vectors are exactly the same, then your cosine theta is going to be 1. If I say uncle, then what will happen? So if I say uncle, then it is man and uncle is 0.2. And if I say man and father, it is again 0.3. So then if I say tomato and potato, okay. And then if we try to see, it is saying 0.8, 0.58. So you can actually kind of get a sense if two concepts are close to each other. Okay. So why cosine is used? Why not sine theta or tan theta? So the answer lies in the concept of vector, not in the concept of trigonometry. So theta, cos theta is actually appearing because of the um, scalar product of two vectors. And if two vectors are close to each other, so there are the closeness is actually defined using two concepts. One, the distance between two points, and the orientation, the angle between the two. So in case of words, if I say like a father has got a length of 2 and then mother has got a length of 1, then it does not make any sense. Okay, because the length is not something which is going to make any sense in terms of words. However, if I put them in a space, imagine if it is a 2D vector, then if mother and father, they are represented close to each other, son and daughter is close to each other, potato, tomato close to each other, then it simply says like the kind of thing that they are, like potato, tomato, they are vegetables, then they has to be close to each other. The father, mother, things are concept which is close to each other, then they has to be together. So if they are together, then angle between them will be smaller. And that's why this cosine theta is coming into picture, because of the dot product, not because of the trigonometrical functionalities. So hope that answers your question. The character and meaning. Now this is a good question actually. What happens? Uh, See, if I look at the real world has got lot of things, then lot of process. Okay, that is going on in the real world. And when it comes to human and maybe some animal also, then we have the concept of emotions. And then when it comes to only human, then there is a concept of faith. So concept of faith, concept of emotions, lot of things that is happening, that is there in the world, those things and those processes that is happening in the world. Okay, so this is the concept that is captured in our text. So what we do, we try to write things in a text for all those things, like your faith or emotions or process or things, and the textual representation of those things. Now, once we have the text in any language, whether it is English or Urdu, Hindi, whatever language we use, it is a representation of the actual thing in a textual format. Now so this is second level what human have done in the past. Okay, whatever people say, like 36,000 it to before we started speaking and creating sentences and so on. So whatever 36,000 year thing that we have done, it is a text. Okay, now on top of the text we are converting into vectors. So that is very important concept. We are dealing with vectors. Now the textual things are gone. Your noun, your pronoun, your grammar, everything is just gone. It is only a vector. Okay. So vector for one word, vector for one sentence, vector for one paragraph. Everything is a vector. Now, essentially, when it is a vector, then what we are saying is that particular in rest of the word description that we are having in terms of text is converted into my multi-dimensional vector space. And this multi-dimensional is right now here we are using 384. Someone may say like I'm going to use 1000 component vector. So essentially you are converting entire thing into a vector space. Now it loses all the discrimination distinctions that was there in the language, like grammar, it has gone. All the senses of words, feelings, emotion, everything is just gone. Everything is now vector. So only thing is like if the vectors are close, it simply means in the textual representation, when they were written in the language, they were coming close to each other or they were connected in a contextual manner. If it is far away, then when the description was there in the textual form, then they were coming close, far from each other. Okay. So if you have thousands and thousands of sentences, you try to understand like which concept is coming close to each other in a very, very repetitive manner. Then in the vector representation, they will be close to each other. And this bridging is done by our embedding model. Embedding model is the engine that actually takes care of that kind of a relationship. So hope that answers your question. It's little complex thing, but if you understand like real world to textual representation, from the textual representation to vector representation. So that's at third level. And from the vector, computers can again come back to text and then generate text for human being. But computer will understand only in the vector form. Earlier it was only binary representation. Now it is a vector form. Everything is a vector form. Exactly. So exactly, yes. What you said is uh, correct. So similarity of the vectors that was generated by the Hugging Face model. Okay. Yeah, so this is what it is. So I try to give you example with different concept like potato and so here I am saying concept because um for computer it's only understand like two things are close to each other, then they will in the textual representation they will come together in a single sentence or in a paragraph. If they are not close to each other, they will not come to. For example, like if you take some, say for example, someone is talking about space. Okay, so you will be talking about moon, you will be talking about light and so on and so forth. You will talking about the Mars, planet, stars, sun. Okay, but if you are talking about something like say for example chocolates, so you will be talking about different flavors, trees, and then different manufacturers who are making shape, size, these, that, wrappers. But if you try to see like when we are talking about chocolates, we will not talk about moon and stars lights. And whenever we are talking about moon, stars and light, we will not be talking about chocolate until unless you are a astronaut, you are gone to International Space Station and there you carried a chocolate and you are eating. So even if you are doing that, the discussion, the text that is going to discuss all those things, we'll have only one or two sentences talking about chocolate and rest of the thing will be talking about space and related thing only. So that is the fundamental concept behind this. Whenever we describe something, we discuss about the related thing in a sentence or a paragraph. And if you talk about some other thing, then you are talking about related thing. And that is the concept. So basically your sentences will be around a concept. And as you change the concept, sentences will be changed. And if you try to capture this into word embedding, then this vector will have that sense of concept across the different sentences or words, whatever embedding you use. That sense is captured into this, and that is done by our embedding models. And that's how it actually making sense. Otherwise, it will not make sense. So different concepts will have cosine similarity will be lesser, and then sorry, cosine similarity theta will be lesser and cosine similarity will be more. If the concepts are far apart, then say for example, if I say tomato and then say moon, then you can see like it is 0.2. So it has gone down because moon and tomato, they are not quite related things. So that's how it is. So you can actually do some kind of experiment and see like the closest concept will have, say for example, if I say brother, and then if I say sibling, then you will see like 0.52. So obviously sibling and brother is quite close. So that's how it is. But you will be surprised to understand like it most of the time it doesn't give 0, because in the literature you will always find something is coming close to other in this various contexts. If not in the normal description, maybe in poetry you will see a lot of kind of thing like moon is connected to some human or something like that. So essentially you will always see like something is connected to some other thing, which is quite weird, but there is some relation some way. So vector similarity we have seen, and then we have also seen. So how do we do retrieval? Okay. So now similarity concept we have understood. How do we do retrieval and how to use this? So essentially, first thing that we have to do is whatever data you are having. So RAG is generally useful for um, the problem where you have, say, for example, a lot of data. Okay. And the data, right now I'm showing only few PDF files, but you can imagine you have a lot of data in terms of thousands and thousands of PDF files, documents, PPTs, Excel sheets. Okay. You can have a lot of books altogether. And then this book is very good for you and you want to maybe search for something, you want to use certain part of the book into something, but you don't want to open the book and you don't have time to go through each of them. If the number of books are, for example, 10, 20 books, 50 books, probably you can even think of doing it. But if it goes into 500 and 1000 books, you will not even have courage to open them, because you understand you are not going to open anyways. Opening 500 book, going through all of them is going to take you months of time. So this is the place where RAG comes into play. You don't have to open the book. It will actually go and search for you and pick the right book with the right portion of the text and show you like, okay, this is the part of the book that you are looking for. And if you augment this with your large language model, then this is going to answer your question right away using the content of the book in a proper language, formatting as per your instruction. So essentially you are going to get formatted answer to your question, you taking the knowledge from your book without even opening the book. Okay, so this is the power of RAG that we are actually going to see right now. So this is my PDF book. What I have done is I have just taken this PDF file and then converted into text. Okay, so this is my textual form of the book. And if you see it, it is not very great, you can say text. Everything just cluttered, no sentence proper, sentence, no heading, no spacing problem is there. A lot of these characters are appearing, some extra thing like slash, square and blah, blah is there. So it's not very good, you can say text to read. And I am opening only one of the book, okay, PDF, which is one chapter in a book. And this entire PDF is for only one book. So this is a CBSE, I think, 10th standard science book. Okay, so we are going to use this as an example. And then each of them are basically one chapter of the book. Okay, so what I've done, I've taken this. So it's very simple. You have a PDF reader, take the PDF reader and convert into a text file. And then our this thing comes into play. You simply provide the path of that PDF, the text folder. So you keep the text folder, text files in a folder and then provide the path. But you can have multiple folders inside one folder and so on and so forth. That is not a limitation. Only thing is we need to have tracking of those things. So in order to maintain that tracking, you create a list of this so that along with the path, you can track it. Otherwise, you will lose from where this particular content is coming. And then we create a something called document with metadata. So here what we are doing is we are reading the document. That is basically we are going to read each and every file. And along with the text, we are going to keep the file name, which is basically this file name has got path of the file along with the name of the file. In between, I am doing two thing. One is your chunk size and this other one is chunk overlap. These two are very simple concept. And you can imagine this is kind of a parameter for you to play with. So what it means is, in your text file here, this has got this is on one chapter. It has got questions, exercises, work examples, and then in that particular chapter, you will have for example, you will have different concepts that are discussed. Okay, so if I say metal and non-metal, so then you can see like physical properties. So here you're talking about only physics. This particular section is talking about physical properties and so on. Then this particular section is talking about chemical properties of this. So in this entire thing will be everything will be talking about chemical property in some sense or the other. So that's how it is. But when you want to get a question to your answer, okay, you are not going to look at everything together. You are going to look at one portion at a time. But the problem is you don't know a priori which portion of the book. So what you do is you convert this entire text into chunks of 2000 characters. So this 2000 number I've just chosen. You can have 1000, 3000, 2500 as per your convenience. Then there is something called overlap. Overlap essentially you have broken thing into parts, but you want some kind of a overlap in between so that suppose while you are breaking, you don't actually look at the text. It's just blind. So suppose if it is cutting in between a paragraph or it is cutting some sentence. So half of the concept will be in one chunk, then half of the concept will be in other chunk. And if you try to retrieve, then there is a good chance that you miss some of the portion of the concept. So it's a good idea to overlap so that it is going to increase your text size, but you are not going to lose any concept. Okay. So this way, the chances of getting a right answer from the question is actually increased. So we have this overlap concept. We have taken the text and then for each chunk, I am putting my file name. So this particular chunk is coming from this file. Okay, so this is how it is ordered now. So we have a list of chunk along with the name of the file. And then this is how it is generated. And then what we do, we try to create a vector embedding. Okay, so we have to create a vector embedding using this particular list. So this list looks like this. We have document, file path, and then we have this content. So file path, content. This entire thing is put in a list, and this particular list is passed to our embedding model. Now embedding model, what it will do, it is going to take the text and for each chunk, it is going to convert into a single vector, the same vector that we have seen earlier. So once we have everything converted into a vector, then your text is gone, chunks are gone, everything is gone, only vectors are there. Okay. So if I try to see like how it looks like, so this is my vector, and then I am trying to see like first vector, how it looks like, my very first vector, and the length of the first vector. So there are uh, 384 components of the vector, and then entire text that we are having is converted into 284 vectors. So my entire book is now 284 vector of 384 dimension. Out of this, the very first one is actually looking like this. So this is what I was trying to say. For computer, when it deals with text using this particular concept, word embedding concept, everything is a vector. Even one chunk that was about 2000 characters is now one vector of 384 component. So now everything is, you can say, list of vectors. Now, if I ask any question, what will happen? It is going to take my question, convert into vector embedding, and do a cosine similarity with all these vector, which is 284 vectors, and rank it. So it will give me the one which is close to my question at the topmost one, and then it will, in the decreasing relevance, it will sort it. Okay. So from there I can pick. I can decide to pick like I want first one only, I want first three, I want first four, because there is a very good chance that your question is connected to concepts which is present in the document at a multiple place. So obviously when you do some kind of a cosine similarity, the numbers will not be exactly the same. Even if they are same, if you pick the one only, then you are going to lose all other. So then it's a good concept that you try to pick some top 5, top 4, top 3. So this is what is actually happening. If I ask a question, what is the difference between conductors and insulators? And I say like, give me top 5 concepts which is close to this question. Now there is one more thing I'm just not using here. This is basically when we ask some question as a human, we are not very clear about the question, or else many times actually we are very ambiguous, in the sense, if you are talking to someone who knows everything, okay, then you need to be very specific. Otherwise, for your question, there may be multiple answers in a multiple domain, in a multiple context. So that's why what happens when you try to write a prompt for a large language model, you have to be like very specific. You define the role, you give a context, you frame your question, and then you ask positive and negative both. Positive in the sense you say like, okay, I need to understand what is the difference between conductors and insulators. And then you exclude, don't tell me about plastic, don't tell me about other thing XYZ. So basically you also try to say that exclude XYZ thing, include ABCD, and so on and so forth. So basically you try to make it, your question, you try to make it more and more specific for the large language model. And it is a very good idea to imagine a large language model as a uh, as a entity who knows everything. Okay. And when we say who knows everything, it simply means who knows everything what is written in text, written by human in text in the past, and that is used for training of the model. So this everything actually within this particular assumption. So there was some question need to drop. Okay. Sir, getting answer without reading entire document, we are uploaded. Yes. So without reading entire document, actually we don't read. We actually do so cosine similarity calculation, and from there we simply sort it out. So you can see the topmost one is talking about my book is this one. JESC 111. JESC 111 is JESC 11 is my PDF. This one. So which is related to electricity. And then if I go to my second one, it is essentially 103. Okay, so this is 103, which is nothing metals and non-metals. So my question was related to what is the difference between conductors and insulators. This particular question is also connected with electricity and current, and then it is also connected with metals and non-metals, which is basically this vector concept was able to pick it very nicely. And there are others also. If we can see like 111, 111, 111. So it says like, okay, the concept is connected to these two chapters only. And then what we do, we take all these text, all five we take, and then only the text part, this text part we combine together and make a single text. Okay. Okay. Now this particular text, I'm going to give it to my Gemini API and ask a question saying that, yeah, give me answer to my question. So let me actually do one thing. I am going to ask Gemini to give me answer to my question like this. So I have got my prompt here. Okay. Okay. So this is my prompt. This is what I'm going to ask my Gemini. Okay. So what I will do is I'm going to copy this and I'm going to put it here. And I will just paste it here. This is my text along with my instruction. So instruction was nothing but my question itself. So you can see the Gemini has actually taken the text and the question and actually giving this answer. Can you see this? And then answer is actually coming from the text that I have provided. So if you have a API working, you can get the answer straight away there itself. But somehow my API was not working. So I'm taking help from the browser. But essentially, this is what it is. We have got a lot of document in PDF format. I have converted into text. The text was not formatted properly, but that is perfectly fine. Then I converted them into chunks, and then I did a vector embedding and created a vector database. Then I am asking question. From the question, it is going and searching for different relevant chunks from the database using vector similarity. It is returning me top 5. I've taken all top 5, converted into text and prompt, and then I'm using that particular text and prompt in Gemini, and I'm getting the answer. So this is in a whatever nutshell you can say, retrieval augmented generation with the concept and one small demonstration with one book. And so I'm almost done. If there are questions, we can take. This is good question. So one thing that we need to understand, the difference between entire large language model approach, or you can say transformer based approaches versus machine learning and your traditional programming. The key difference here is machine learning to some extent is deterministic, And our programmings were 100% deterministic. However, when it comes to large language model, they are heuristic. Heuristic in the sense, if you ask same question with the same context, everything, answers will vary. So what we do is, we try to limit that variation or control that variation using proper context and then formulating your question properly. So and that's where the weakness of the RAG also comes into picture, in the sense, if your prompt on top of the text is not proper, it is going to fail. Like for example, I have written this, but this is not very, I mean, this is one liner may not be sufficient in all the cases. So you have to write more such lines to make your answer very, very precise in terms of information, in terms of representation. It should not be like very, very innovative and adding 10 more thing on top of your text. That should not be the case. Then what people do, once you get the answer, then you can put one more layer on top of it, saying that, okay, let me use my vector similarity to find out how close my answer is with my question. So this is actually giving one more check, saying that, okay, if the answer is close to your question, probably the answer is correct. So then, I mean, these are some kind of limitations RAG is going to feel. And then if your chunking are not proper, and then your vector embeddings are not proper, probably retrieval will fail or retrieval will not work properly. There also you have got the limitation, meaning there is a chance that you miss some very, very key information in the document and you pick the one which is not that strong. That is also one of the thing. So to address this, what we do, along with the question, you also try to rephrase your question by adding some more information with the question. So what will happen, if the along with the question you get more, you add more thing, your concept becomes stronger and retrieval becomes more meaningful. So there are few things where it fails, and there are some ways to handle that. For a person trying to learn these texts, what is the learning path and resources? Deep learning.ai, they have got a lot of short courses. Coursera has got a lot of courses. You can actually go and enroll yourself and do the courses. Deep learning.ai is very good, in the sense 1 or 2 hour courses, very small courses, and they're all free. Only problem is you need to have some prior knowledge, otherwise most of the thing will not make sense. So that is the caveat. So depending upon your level, if your level is very low, I mean, you want to start, then Udemy is better, because their level of lectures are very, very, I mean, simple, and they try to explain in a very, very basic sense. Coursera and deeplearning.ai, they try to start at some level, because most of the time these people are professionals, and they are working on day-to-day things. So they don't, they will not go into basics of the things. So that is, I mean, Udemy plus Coursera plus, or not plus, or Coursera or deeplearning.ai. So can you explain what are token? Token, see, as a human, we think in terms of words. So what happens when we think of computers and different architectures, right? So what happens? They have got the limitation of length. So your input, suppose you define a function, you say like my input is, my function can take 2 inputs. But if this 2 is not fixed all the time, you are going to face problem. So what they have done is, actually computer does not understand what the word is. They understand the sequence only. So what they have done is, they have taken everything into their consideration, whether it is your normal characters, is by your space, your special characters, new line character, whatever is there in that text, they simply take it, and then they break into fixed size, you can say, characters, and that is they call token. I think the length is 6 or 8 or something. That can vary, but this is how it is. And that one token may contain spaces, may contain part of the word, full word, maybe more than one word, depending upon the size of the word. So that's what it is, token. So token has got fixed length, and that is the important thing, because once you have the fixed length, you can handle in your architecture easily. So that's what the token is. Um, how do you handle when we have a lot of data and you use Gemini or okay? So we don't give lot of data to Gemini or anything. The lot of data that is get generated from my document is actually stored in my database. So you can see my database here. FASSI, where is that? FAS database. This one. So this is my database. So I'm using this database. I've done the embedding and stored it here in my local machine. And then retrieval again local machine. After retrieval, I have only got 5 chunks. So each 2000 characters. 2000 multiplied by 5, that is 10,000 characters. So 10,000 character is my context length. And on top of my asking question. So for Gemini or any large language model, it is always 10,000. It is never more than that. Can we have a chapter name from where the text? Perfect. No problem. So once you got the document from where it has come, its chapter name, file name, a lot of things are basically metadata. So you can extract it from the document itself, or else you have chapter name separately in the document, and then simply you want to put it, you can put it. It's all metadata. Structured data, does it also unstructured data? No, what we have seen is unstructured data. Text is never a structured data. Structured data means columns, rows. We don't have columns or rows. So it is basically purely for unstructured data. Here we are dealing with text. You may have numbers also, but numbers without a structure does not make much sense. But yes, text always makes sense without a structure. Okay. For example, if I am building a guide for a company or business that has all the know about it, assuming it is a small business and the information is only about say 200 words, then should be still not needed because 200 words you can read in a minute or so. So it is overkill. Why you want to use cannon to kill a mosquito? I mean, you can do it, but it's not advisable to do that. It is more costly, right? So will give you more accurate information. No. I mean, it's overkill basically. If FS is good enough, should we go for? So no, actually there is no single answer for the database. Depending upon your requirement, your document size and so on, you should use your databases. I have used this FAISS. You may use Chrome also, but you have to do some kind of a reading, like which database is good for what kind of problems and so on, and essentially the speed of retrieval and so on. So just do some kind of reading and then choose. I mean, there is no single answer, I would say. Any research intern opportunities at TCS? If yes, BTech 4 year student. Actually, intern opportunity is a good question. But we take summer intern, which is starts in the beginning of May. So right now we are closing intern. For next year, you can apply through your whatever placement office. Just connect with your placement office. No master PhD. BTech also can apply, masters can apply, PhD. Is no such criteria. Just connect through your placement office. They will connect to our HR and that's it. It's very simple. No, image and video is like this. Image is basically array of pixels. So until unless you convert your images into text, RAG is not going to make any sense because it is working on word embedding. You need word. So if the image is of text, then yes, you can do word embedding. First, you have to extract text. If it is images, like some pictures are there, then we have a different model for that. That is called vision model. So essentially, if you give the image, it will describe what it is. Then video, again, like video is a combination of images and text, audio. Audio you can always convert into text, and then once you have text, you can use RAG. And then obviously from video, you have timeline, then you have conversation, then you can pick the conversation from your RAG, and you can actually like metadata, you can go back to your timeline and pick your exact time where this particular conversation was happening in the video. So that way, yes, we can handle videos, but root is you have to convert video to audio, audio to text, and text to again chunk, then chunks to RAG. Then your Gemini, if you want to use for answering your question, yes, you can do, and then plug it back to your timeline. So that can be done. What are the key uses of RAG? Basically, one line answer would be like if you want to chat with your data, you have a lot of data, you want to chat, you want to ask question, you want to get answer from the data itself. That is the ideal, but you can have a lot of innovative ways to use RAG. I mean, there is no limit actually. This is just technology, and then you can use it in different ways. Traditional AI like MLDL, essentially what happens once we have retrieved the data text. So essentially you have seen like it is a I mean 10,000 characters, right? So from 10,000 character, if you want to have a crisp answer to your question, that's where large language model comes into picture. But in case you simply want to read it yourself, you don't require any of these AI, ML or LLM things. So I would say it is based upon your need, how you want to consume the outcome. But a large language model on top of the text, they actually make it more clean, good to read, and so on. ML and DL essentially they don't work on text. NLP concept they work on text, but if you have some kind of NLP concept, you can use on top of the retrieved chunks. So that you can do. I would say essentially even your NLP concepts where you have entity relationship and so on, either they are working on dictionary or they are working on again vector concept. So yeah, that is your answer, but I would say LLM only. What did you use to convert PDF to? So there is a PDF reader in Python. You simply search for it. There is a PDF reader. It will read for you. In case your PDF is basically contains a lot of images, or the PDF itself is just image, not a text, then you have to convert the PDF into series of images for each pages, and then use OCR, that is optical character recognition. There is a package, Python package for OCR. Use that, and then you have a text. 10 years experience guy in backend. What model will you suggest to get into Gen AI NLP? Um, it's a little difficult question, but I would say there are two things that we need to focus on. This machine learning, deep learning, and Gen AI concepts, they are deep. At one side, they are deep into programming and stuff related that, and on the other hand, they are also connected with your mathematics. Some of the mathematical concepts like vector we have seen. Then some of the machine learning concept they use matrices as their core concept. For example, dimensionality reduction is completely based on uh, your principal component analysis concepts that is there in mathematics. We have seen this kind of concept in our BTech mathematics courses. So what I would suggest is you have to make a balance of three things. One, your computing environment, for example, cloud you are using, your personal machine you are using, or some server you are using. So then GPU and CPUs will come into picture. Communication related stuff will come into picture. Second thing, your core concept. So do not try to learn everything. You try to see like what is my application, where I'm going to heading, and based upon that you choose which one to understand. And the third thing that you have to do is you have to brush up your some of the mathematical concept. Because if something goes wrong, your understanding is going to help you other than your chat GPT and Google. So if they fail, then it's only your understanding that is going to save you. So generate some understanding. It gives you confidence. It makes you understand how it is happening, why it is happening, and so on. If something fails, then or something is not working, even if it does not fail, it is not working as per your expectation, then you know like why it is not working, because of the certain limitations in the core technology itself, it may fail. So if you have understanding of the core technology, then you will not expect more from the technology. So that way understanding actually helps. Most of the time your chat GPT is going to answer your question, but reasoning, fundamental reasoning, if you have the understanding, then you will be more comfortable. That's my suggestion. You can decide like what to do. Any specific reason using Gemini, can we use? Yes, yes, we can use. Actually, I tried everything with Gemini, so I didn't want to do experiment in the demo, but you can use it. I mean, there is no specific reason. It's only thing is you have a text, you have a question, you want the question from the text, and you want to format in a proper way. That is the role of the LLM. So, no more question. Last question was Ahmed by Zia, Ahmed Mansuri, Ahmad Mansuri. Yes. Any more question we can take, or else we can conclude. And also your feedback. How was it? Was it easy, difficult, too verbose? I was talking a lot. I mean, was it able to convey the thing? And is there any difference in your understanding before the session and after the session? That is more important. Okay, good practical. Okay, thank you. Okay, thank you. Some detail on continuous learnings and corrections of the LLM are stored in what format? Learning and corrections. Format, I said it's the vector form only. Um, Inside the database, how it does, maybe some space optimization, I don't know really. Maybe if you can explore and share, that will be great. But it is vector, essentially. Um, Learning and corrections, I could not understand this question really. Too much clear, okay. Very interesting, good learning. Thank you. Thank you very much. Um, Evaluation metrics to check the accuracy of the retrieval or answers. Actually, there is a course in deep learning.ai. People are working on this. I would not say like they have solved the problem 100%, but people have realized that there is a accuracy issue. And if there is a matrix which they can utilize, and then from there are two things. One, if there is an error, can I fix it? Can the system itself understand and fix it? That is good. Or else if there is an error and the system just tells that this answer is actually not correct along with the answer, even that is good, because I will know that okay, this answer is not correct, I will do something. As a programmer, I would like to understand some kind of flag. So I would say people are trying. There are courses, I have seen one two courses I've attended also, but frankly I would not say like they have solved the problem. I mean, you can explore, but you can say it is complete. Till now, it is an unsolved problem. So, what is actually happening is using all these techniques, we are able to do a lot of work, but without human supervision, there is a big risk associated. One person can do a lot of work, but without human relying 100% on these things is very, very risky. This is my reading as on today. Tomorrow it may change. I'm not sure, but this is what it is. So yeah, I mean, if you are a manager, you are a company owner, if you want to take decision, just take this in your consideration. With top topic, how difficult it is to fine tune our pre-existing model. Like, yeah, fine tuning is a task. Essentially, you need to have a lot of things. Your compute resources. You need start with a good model. Then you have to have data, format the data as per the requirement, and then train it. So if you are interested, Fanmai, then you can explore Hugging Face. Hugging Face, I'm typing. Hugging Face. This is the website. They have trainable models. They also give some kind of instruction how to train if you are interested. Infrastructure setup need to be done likely in any other setup. No, I was doing this completely based on Python. So I think I have given the link. You can go through it. And then file itself is very simple. Now a specific thing is required. Actually, what happens, the infrastructure requirement comes when you are actually running your LLM, which is very, very heavy. So they're only required for all these things, very simple computer. I'm using my laptop. So it works without any problem because the problem itself is very simple. But if you have a big problem, probably embedding and all will take more time. What are the competing architecture compared to RAG architecture frame? It's not competing, I will say they are complementary. So there is something called RAG knowledge graph. Probably I will take this also in some time. So essentially there is something called graph. There is something called knowledge graph, wherein if you take a book, it converts into a graph structure of the entire book or multiple books for that matter, and then traversing the graph and reaching to the right node where the knowledge is stored as per your question, and then from there retrieving it back and then answering your question. This is something people are exploring, and they are saying that knowledge graph based RAG is more powerful than pure RAG. I mean, this is something people are saying. I've not experienced it yet. We'll experience and share maybe in some time. So there actually knowledge graph is helping in retrieval part. So it is not completely dependent on vector. It is first through branching, it actually goes to that particular area, and then from there it actually picks. So it's kind of double layer retrieval approach, you can say. Tomorrow, no. I'm not aware. Maybe Saibhai can help. I'm not aware. Tomorrow I'm not going taking any session. Yeah. Okay. I think if you don't have more question, we can conclude it now. So still there are 35 people. Thank you very much. Thank you for your time.